Hello class, this is Ms. Martins and we are in Unit 8 Energy. Today's objective is students will be able to calculate the heat of fusion and vaporization given the HF and HV constants. So if you can recall, the heat of fusion is the phase change between a solid and a liquid. So when a solid is changing into a liquid, that is going to be melting. And when a liquid is changing into a solid, that is going to be freezing. So melting and freezing points occur during the heat of fusion. That is the phase change that we're going to classify as heat of fusion. Heat of vaporization is the phase change between a liquid and a gas. So when a liquid is changing into a gas, it is evaporating, hence the name vaporization. And when a gas is going into a liquid, it's going to be condensing. So condensation and evaporation occurs during the phase change of heat of vaporization. We're going to go over two questions that can help us to understand if we understand these concepts. So the first question states, the heat required to change 1 gram of a solid at its normal melting point to a liquid at the same temperature is called the heat of. So we're trying to change 1 gram of a solid and melt it to a liquid. Which one of these occurs during melting, which is a heat of vaporization, fusion, reaction, or formation? Based on the previous slide, and if you listen to the first lesson in Unit 8, the heating/cooling curves, we'll know that our answer is 2, fusion. If this is kind of confusing for you, I would recommend going back to the original video, the heating/cooling curve, before continuing on with this video. Question 2 states, pause the video, try to answer it before I answer it. The heat of fusion of a substance is the energy measured during A, is it 1 phase change, 2 temperature change, 3 chemical change, or 4 pressure change. So the heat of fusion is going to occur and is measured during a phase change. So we're just going to go over the heating curve once again. Which line segment represents H of F? It's going to be between the B and C. This is where melting and freezing occurs. Which line represents H of V, which is the heat of vaporization? That is going to be between D and E. This is where boiling occurs as well as condensation. So remember, the phases are solids, liquid, and gas. And during a phase change, which is going to be during where heat of fusion and heat of vaporization are, the temperature remains the same on our heating curve. Also, during the heat of fusion, during the melting point, the state is going to be between a solid and a liquid, and here is going to be between a liquid and a gas. So both states can be found within these phase changes. So going back to our main objective for today, you guys will be able to calculate the heat of fusion and vaporization given the HF and HV constants. The steps for success for getting this done is first you're going to determine the equation that you need to use in order to determine either the heat of fusion and vaporization. You're going to place the given values X for unknown, and then you're going to solve for the unknown. So heat of fusion, before we continue, and heat of vaporization are energy constants. So they're a form of energy. You can find the equations for this in the reference table on page 12. The equation is as follows: Q equals M H of F, and Q equals M H of V. H of F stands for heat of fusion, H of V stands for heat of vaporization, the M stands for mass, and the Q is going to stand for heat, which is just energy. The constants, so where we see H of F and H of V, you can find the constants on page 1 of the reference table, table B. The constant for heat of fusion is going to be 334 joules per gram, and the constant for heat of vaporization is going to be 2,260 joules per gram. And we're going to understand how to use these constants and these formulas with the next 3 examples that I'm going to go over. The first example reads, what is the total amount of heat required to vaporize 1 gram of H2O liquid at 100 degrees Celsius and 1 atmosphere? So they're asking us for the amount of heat required to vaporize. So therefore, we have to first determine our equation. If we're trying to vaporize, we're going to be using the heat of vaporization equation on the last page of the reference table. The constant for H of V is going to be 2,260 joules per gram. So we're just going to plug that into our formula. Our grams given in the question is 1 gram. We're going to multiply that by 2,260 joules per gram. And our heat, our answer to this question is 2,260 joules. Joules is going to be our units for energy. If you have any questions, make sure that you comment in the Google Classroom or watch this video as many times as you need. I'll always be here. You can always email me as well. So the next question that we're going to be going over. What is the minimum amount of heat required to completely melt 20 grams of ice at its melting point? So if you can recall, melting is going to occur during heat of fusion. So we're going to be using the heat of fusion equation. Q equals M H of F. The heat of fusion constant is 334 joules per gram. So we're going to be plugging in that number into our equation. And we're looking for Q. The mass is given here in the question. So we're just going to multiply 20 grams times 334. And that gives us our answer of heat is equal to 6,680 joules. And for our final question, it reads, base your answers to the following questions on the information below. Heat is added to a 200-gram sample of H2O solid to melt the sample at 0 degrees Celsius. Then the resulting H2O liquid is heated to a final temperature of 65 degrees Celsius. Compare the amount of the heat required to vaporize a 200-gram sample of H2O at its boiling point to the amount of heat required to melt a 200-gram sample of H2O at its melting point. So they're asking us to pretty much determine the heat of vaporization as well as the heat of fusion. So the heat required to vaporize as well as the heat required to melt. And then compare the two numbers. So I'm just going to plug and chug. The first formula reads Q equals M H of F. So I'm going to multiply our grams given in the question, 200 by 334 joules per grams, which is the constant for the heat of fusion. And I get 66,800 joules. I'm going to do the same thing for the heat of vaporization. I'm just plugging in the constant of heat of vaporization into our formula, multiplying it by the 200 grams given in the question, and my answer is going to be 452,000 joules. And then I'm going to divide the two numbers by each other in order to compare them. 452,000 divided by 66,800 is going to give us 6.77, which is approximately 7. So I can say that the heat necessary to vaporize 200 grams of water is about 7 times larger than the heat necessary to melt 200 grams of ice. So if you have any questions on any of these questions, please feel free to reach out to me. I'm going to post a bunch of practice questions for you guys to work on to ensure that you understand this topic. The exit ticket is just to work on those practice problems. They're going to be on a Google form. If you have any questions, once again, please email me or write in the comments of the Google Classroom. I'm always here for you. Stay safe and be well. Thank you for listening to this lesson.